So let us take another example. In this question, you're given that if a greater than 0, prove that this cubic equation x cube plus ax plus b is equal to 0 has two complex roots. So how do we do this? So let us use our Descartes' rule of signs. So there are two cases, right? A is given as positive. B can be either positive or negative. So let us take the case 1. If B is greater than 0, then what is our conclusion? So if B is greater than 0, from the Descartes' rule of signs, the signs of coefficients of f of x is nothing but plus, plus and plus, because 1 is positive, A is positive, and we have assumed that B is positive. So plus, plus and plus. There are no change of signs. Hence, f of x cannot have positive real roots, because the maximum number of positive real roots to the equation f of x is equal to 0 is the number of changes of sign in f of x. There are no changes of sign in f of x, hence the equation f of x is equal to 0 cannot have positive roots. Next, consider f of minus x. F of minus x is nothing but minus x cube, and if you put minus x in the place of x, you get minus ax plus b. So what are the signs of this? Minus, minus and plus. Now how many changes of sign are there? You have no change here, one change here. So one change of sign. You have only one change of sign. This implies f of x can have a maximum of one negative root. So it cannot have any positive roots, and it can have a maximum of one negative root. Can have a maximum of one negative root. This implies f of x can have a maximum of one real root. So positive roots and negative roots constitutes all real roots. So can have a maximum of only one real root. But in a total, this equation has 3 roots. So what should be the remaining 2 roots be? So this implies f of x has a minimum of 2 non-real complex roots. So it has to have at least 2 complex roots, because complex roots always occur in pairs. All 3 cannot be complex. So it should have a minimum of 2 complex roots, and it has 2 complex roots, because all the 3 roots cannot be complex. Complex roots always occur in conjugate pairs. So if b greater than 0, we have proved that this equation has 2 complex roots. Next, what if b less than 0? If b less than 0, the signs of f of x are plus, plus, minus, positive, positive and negative. So one change of sign, one COS change of sign. This implies a maximum of one positive root. Now f of minus x is nothing but minus x cube minus ax plus b, but b is negative, so you have all negative signs. So no change of sign. This implies no negative roots. So have a maximum of one positive root and no negative roots. So which implies that, what does this imply? This implies that a maximum of one real root, and this implies a minimum of two complex roots. This implies exactly two complex roots because it cannot have three complex roots. So complex roots always occur in pairs. So a minimum of two complex roots for a cubic equation means that it has exactly two complex roots. So using Descartes' rule of signs, we have deduced that this sort of equation always have two complex roots. Thank you.